Hello, welcome back to the course Build Dynamic Model of Electrical Vehicle with the help of MATLAB. Initially, the aim of this course was to explain how we can connect the vehicle model with the electric motor model and with the power electronics of electric drive, so that we can predict the performance of electric vehicle when it combined with the motor and power electronic system. So it was expected initially that only electrical engineering students are going to enroll in the course. But with time, lots of students from the mechanical as well as the automobile background joined the course, and now hundreds of students are there from mechanical and automobile background. So they consistently request for the rolling resistance and ask question about why rolling resistance is not included. So here I decided to finally come with the rolling resistance and its simulation with the electric vehicle model. So because what we studied how to develop the simulation model of the vehicle in the MATLAB, now we can add any kinds of opposing force. But if we first understand the rolling resistance, it is nothing but the frictional force which is opposite to the applied force. Now what force we considered during the simulation and mathematical representation of the vehicle was only MA and FD, that is aerodynamic drag force and force due to weight, MA. This is F is equal to MA and FD, both are in Newton. So if we apply the force in this direction in Newton, these two forces will be opposing it in Newton, and we have to overcome this, so that some minimum force need to apply to achieve the constant acceleration and velocity. So now when we talk about the rolling resistance, it is the frictional component. So why it is there? Because if we understand the wheel and if we look at this 2D diagram, it's look like there is only one point of contact, or we can say there is one point which is attached with this surface. That means this wheel and vehicles connected to the surface with only one point. But if we look at the width of the tire of the vehicle, then this point will become line. And even if we consider the rubber tire and there is some deformation of the tire, then this line will become the area. So when we consider the only point friction, this friction will be very less. But when it comes to line, there will be more friction, and even if we add the deformation, that means it become area, then again friction will be very high. So if you look at this tire in 3D like this, that means now there is this width, and if it is deformed at this due to pressure and weight, then it will become area. So with this opposing force will increase and we need to consider it. So this is called the frictional force, also called the rolling friction or the rolling resistance. So this is nothing but opposing force in Newton, which is due to the type of the tire, material of the tire, and weight of the mass, and also velocity depend on this parameter. So if steel tire is there and if this is also steel structure, that means like the train rail, this frictional losses will be very less. That means this frictional component which is opposing the force will be less. So there are also some method to test it. That means if you roll this and if you remove the applied force, it will roll for more duration or for more distance when rolling resistance is less or when rolling friction is less. So if steel tire and steel rail, and if you apply some force and at certain velocity, if you remove the applied force, then it will continue to roll on this surface. And if rolling resistance or rolling friction is less, it will roll for more distance or for more time. So this way we can also measure the rolling resistance. So let's understand the mathematical representation of this opposing force. So rolling resistance is called the rolling frictional force is equal to one constant into W. W is m into A. A is the gravitational constant and m is the weight of the body. So the opposing force Fr, which is due to rolling resistance, is m into A and multiply by 1 rolling resistance coefficient. Now value of this coefficient is very less, 0.001 or 0.01 depending upon the tire type and surface. So we need to understand this. So it can be neglect in some case like the bicycle and bike, but when the width of the tire is increased or rubber tires are there, it will slightly more. So we can simply add this opposing force to equation that we developed already and to the simulation model also that we developed. So what we will do, we will also do the simulation with this rolling resistance coefficient and we will also check different conditions. So this is one more opposing force we are going to add in the equation we have developed. Here A is the constant, 9.81 meter per second square, right? That we know, and m is the weight. So this is the equation of the vehicle we derived. Only the Fd is opposing force into ma, and this is due to this slope gravitational component mg sin beta. So here we will add one more opposing force which is called Fr, rolling resistance force in Newton, C into W. So our new equation will become like this, and this equation we use for modeling will become like this. Now there is minus C into W and here plus C into W. So simply by doing this you can update your equation, nothing else, right? In simulation model you can just add this force if you know the value of rolling resistance coefficient, and Fd is as it is that we discuss. So here are some typical value of the rolling resistance coefficient with different road condition, surface condition and tire condition. You can go through different literature also and you will find also different value of rolling resistance. Now one more thing we need to understand, rolling resistance also depend on the tire pressure and the speed, that is velocity. So that coefficient itself is not constant. So we can also go through one more level of the simulation by the dynamic rolling resistance. So instead of adding the constant resistance C, we can also add the dynamic rolling resistance in our simulation. With this simple equation we can calculate the new coefficient which depend upon the pressure and speed. So tire pressure in bar in this equation and velocity in kilometer per hour. So if we put these two value, then we can find the value of rolling resistance coefficient. I will share the link in the description for this reference from where I taken this equation. If we have the case, then standard wheel pressure in Tesla Model 3 is 2.9 bar. Here with the same speed 90 km per hour, I just change the value of pressure. So to understand if pressure is increased from 2.9 bar to 3.5 bar, the value of rolling resistance is changed from 0.011 to 0.010, right? So high tire pressure with low rolling resistance. You can also calculate the opposing force in Newton if you have the value of mass, right? So this way you can calculate it. We will understand in simulation also, and we will also see some case study in simulation how to add the rolling resistance. Now if we look at the effect of rolling resistance, it is the high power consumption and less efficiency. So we always want the rolling resistance as minimum as possible, right? And if we discuss about the testing method for the rolling friction and rolling resistance, so there is retardation test, power consumption test and the top speed test that can we do in the simulation also to find out whether rolling resistance is increasing or decreasing, or what is the acceptable limit of rolling resistance, and also we can understand the variation in rolling resistance and its effect on the power consumption, and effect on top speed, and effect on retardation time.